Alright, let's talk about the multiplication rule for independence. One key thing to note here is that if A and B are independent events, then the probability of A and B is the product of the two probabilities. So it's important to make sure you're reading the problems to understand what you're being asked. So if we're reading through this probability example, if A is the event that the light is green, B is the event that the light is red. The two events are independent. So in order to determine the probability that it's green on Monday and red on Tuesday, it's simply going to multiply the 0.42 and the 0.55. So if you're asked for the probability, you're just giving me the value. You only need this part if it asks you for a written explanation in terms of what does that probability mean. So what's the probability that Pedro finds the light red on Monday through Friday? So again, it's just multiplying it for each day of the week. So 0.55 times 0.55 and so forth. And that will give you your answer. So read through the next example and see what you get. Alright, so let's look at excuse me, important information here. So we have the probability that the O-ring joint would function properly under cold condition was 0.977. Alright. So we're going to find the probability, assuming that the joints succeed or fail independently. We're going to find the probability that the shuttle will launch safely. Again, it's 6 of them, so we're multiplying that 0.97 times 6 and getting our probability. Alright, so this next example takes us through finding the probability of at least one. Okay, so the challenger would not launch safely under similar conditions if 1, 2, 3, 4, 5 or all failed. That is representing that at least one. So the events for at least and O-ring spell are complementary. So in order to find this probability, we first find the probability that no rings fail, and then we shall subtract 1. So if the probability that no rings failed is 0.87, subtract 1, we get to 0.13. Alright, so read through this next example and try it independently, then come back to the video. Alright, so if you read through this information here, again, the important thing here is the probability. One rapid test has a probability of about 0.008 are producing a false positive. So the probability that there are no false positives is 0.992. So if a clinic tests 200 selected people who are free of the antibodies, the chance of at least one false positive, you're going to multiply that 200 times and get your 0.201. And once we get that, subtract 1 from that, and we get our probability of 0.799 of at least one false positive. So government data shows that 8% of adults are full-time college students and that 30% are 55 or older. We randomly select an adult. The probability to full-time student and over 55, 0.8 times 0.30. Why not? Take a moment to think about it before you answer. And there you are. They are not independent events, so this cannot be true. So remember, the rule maybe today only works if they are indeed independent events. So take a moment, try the lesson app, check Schoology for the results, and complete the worksheet. So here, 5% of the tests receive a positive results. There's your 0.05, which means 95% receive negative. There's your 0.95. You're multiplying them together to get your answer. And we got 100 unrelated women with normal pregnancies tested. Probability is that at least one will receive a positive test. So we need a probability that none are positive. And then we're going to multiply. So we take our probability for negativity, and we're going to multiply that 100 times to get our answer. And then subtract 1. So again, it's going to be important to read the problem and understand what you're being asked for. So make sure you go through this. If you need to rewatch, please do so. Please collaborate, and I'll see you soon.